Hello students, welcome back to Physics with Ashwini. In today's class, we are going to discuss some very important and interesting concepts from mechanics that are frequently asked in your competitive exams. We will begin with motion of connected bodies today, where two or more objects are linked and move together under certain conditions. After that, we'll understand the famous Atwood mission concept, which is one of the best applications of Newton's laws. Next, we will move to constrained motion, where motion of one body affects the motion of another due to strings, rods, etc. etc. And finally, we will learn about impulse and change in momentum, which explains what happens during collisions and sudden forces. So stay focused till the end because today's session will strengthen your concepts and boost your confidence in solving numericals. So we'll begin our session, motion of connected bodies. So as I said earlier, connected bodies, one body will be connected to other body. If they are directly connected, what force can you expect at their contact? You can expect a normal reaction. See, normal reaction is basically a contact force. When two bodies are in contact, there will be a perpendicular force called normal force or normal reaction. So we'll see the concept now. Let this be the horizontal floor. For the sake of understanding, I'm just taking three bodies. M1 is the mass of first body, M2 is the mass of second body, and M3 is the mass of third body. Now, if you see, how are the three bodies here? They are connected, right? They are connected to each other. Now, for suppose, if I apply some external force on the mass M1, that means I am applying external force on the first body. This is the force applied. Now, what happens to this M1? We have studied in the previous class, right? So, whenever a force is applied, there will be a change in state of the body. So, now the body possesses certain acceleration A. So, M1 moves with acceleration A in the forward direction because that is the direction of force applied. Now, what about M2 and M3? As they are connected to each other, they also move forward with the same acceleration. And this is what called the concept of motion of connected bodies. If the bodies are connected to each other, the force applied on one body brings the acceleration in other bodies as well. Like if you take M2 and M3, there is no direct application of force, but yet some acceleration is created in them. Why is the acceleration created? Because they are connected to M1. We are actually applying force on M1, but you can see motion in the connected bodies as well. Okay. Now, where is this normal reaction? If you see M1 and M2, there is a contact between them. You can see the contact here, right? So, at this contact, you have to consider a perpendicular force. For suppose if I want to see how much is the force on M2 by M1, that is N. Similarly, how much is the force on M1 by M2, that is also N. Same contact, normal reaction value also will be same. Now, let me call it as N1. Now, if I take this specific contact between M2 and M3, so M2 will exert some force on M3, that is normal reaction. M3 will also exert some force on M2, that is also normal reaction, but this is not equal to N2. This is different. This is not equal to N1, sorry. Because the contact is different, so normal reaction is also different. Got this point? So, where can we expect the normal reaction? At the contact of two bodies. Now, important points to remember. First one, what is acceleration here? It is nothing but net force upon net mass of the system. What is the net force in this entire system? See, M1, M2, M3, they are connected, right? Now, this all together is called as a system. So, what is the net force on the system? It is F. You may get a doubt, ma'am, N1, N2 forces are also there, right? They are there, but they are internal forces. Now, if you see on M1, if there is N1 force, M2 also there is N1 force, and they are in opposite direction, so they will cancel out. Similarly, if you take between M2 and M3, N2, N2, they are in opposite direction, so they will cancel out each other. So try to see the external net forces, okay? So external net force is only F for this diagram. And what is the M net? What is the total mass? It is M1 plus M2 plus M3. So this is the A net. So what is the acceleration produced in this system now? It is F net upon M net. Any difficulty? Very simple. Bodies are connected. If one body undergoes motion with acceleration A, the others also will undergo motion with the same acceleration A. That's it. And how is that acceleration? How will you find out that? Using F net by M net. Now, in exams, you will get the questions like find out the value of N1 and N2. What is a normal reaction between first body and second body, or between second and third body? You'll get such kind of questions. So, what you have to do in that case, you have to consider the free body diagrams. What is a free body diagram? So, you just have to isolate the body. For suppose if I take M1 now, I'm just isolating it from the system. You have to indicate all the forces acting on it. What are the forces acting on it? There is F in horizontal direction, and there is one more force in backward direction, which is your N1. Now, what you have to do, just apply Newton's second law. F is equals to ma, but here two forces are there. So, you should take F net is equals to ma. And what is F net? F minus N1 or N1 minus F? How will you decide that? You have to decide that depending on the direction of motion. So in this direction, the system is moving, right? So what you have to do now, you have to take F minus N1 is equals to M1 into A, because M is M1 here. Clear with this? Similarly, if I take M3 body, I'm just isolating it. How do you construct the free body diagram now? What are the forces acting on it? There is only one force on it, which is N2. See the diagram. There is only one force on it, which is N2. Now, if you apply F net is equals to ma, there is only one force. So, N2 is equals to M is M3. So, M3A. Clear with this? So, you got the N2 value. And F is given in the question. If it is a problem, they'll give some data, 10 newtons or 20 newtons. F value will be given. So, if you substitute that, here you can find out N1 value as well. So what you have to do is, in order to find the normal reaction, construct the free body diagrams for each mass. Write the equations using F net is equals to ma, simplify them, you'll get the answers. So just recollect once what we have discussed. Clear? Fine. Now there is a question. See this and try to do it on your own. A horizontal force of 10 newtons is applied to block A. So force is applied on which block? A block. You can see the figure here. The mass of blocks A and B are 2 kg and 3 kg. Fine. And they are interconnected if you see. So they are directly connected. So what will be the contact force here? It will be a normal force. The blocks slide over a frictionless surface. That means there is no friction here. So there is no headache of frictional force. The force exerted by block A on block B. See, A will exert some force on B. What is that? Don't you think it is normal reaction? What is the force exerted by A on B? That is actually normal reaction. So they are asking what is the N value. So what do we do? What is the first step? First step, we'll find the acceleration, which is F net upon M net. And don't consider internal forces for F net. So there is only one force, so 10. What is M net here? 2 plus 3. So how much will you get? 10 upon 5, which is 2 meter per second square. This is the first step. And second step, what do? We have to take the free body diagrams. See, you can take for A or B, that is up to you. Whichever you take, no problem. So for simplicity, I'm just taking B. I'm taking the B block whose mass is 3 kg. And there is only one force on the B block, that is because of A. A is exerting normal reaction on B. Now if I apply F net is equals to MA. What is F net? Only one force, that is normal reaction. M is nothing but 3 here, and acceleration is how much we have calculated here. Just substitute here 3 into 2. So how much is this? 6 newtons. So what is the force exerted by A on B? It is 6 newtons. Clear? Similarly, what is the force exerted by B on A? As I told you, normal reactions are equal and opposite here. B will also will exert same 6 newtons on A. Okay, but that is not our question, so leave it. Now, same concept, motion of connected bodies, but this time, if you see the figure, it's pretty clear. They are not directly connected. They are connected with the strings. Strings, rope, all mean the same. So what will be the force in string or a rope? It will be a tension force T. If bodies are directly connected, we consider normal force. If it is a string or rope, we consider tension force. And what is the direction of tension force? It will be away from the mass. The direction of tension force will be away from the mass. Like see the figure, three bodies are there, M1, M2, M3. Their respective masses are M1, M2, M3. Now if I want to see the tension on M1, it will be away from M1. Similarly, if I want to know the tension on M2, it will be away from M2. Similarly, if I want to know the tension on M3, it will be away from M3. Got my point? And remember one thing, in the same string, if the string is same, the tension force will also be same. So same string, there will be same tension. If you take M1 and M2, they are connected by string 1. Let the tension be T1. Now if you take M2, M3, if they are connected with some other string, what will be the tension here? It will be T2. So if string differs, tension differs. If the string is same, tension is same. Now what I want you to understand is the tension force on M1, tension force on M2, it is same. Similarly, tension force on M2 and M3 is also same. T2, T2. Got my point? Fine. See, what is the difference between previous case and the present case? They were directly connected in the previous case, whereas here they are connected with some rope. That is the only difference. And here if you apply force on one body, you are applying force on third body. So that moves with some acceleration A, and the same acceleration will be produced in M2 and M1 also because they are connected. Clear? Now, same formulas we have to use. First formula you have to find the acceleration, which is F net upon M net, F total upon M total. And next you have to construct the FBDs, that means free body diagrams. For suppose if I take M3 here, some external force F is applied on it. And to the back of it, there is a tension force T2. So if I apply F net is equals to MA for this, what do I get? What is the direction of the motion of the blocks? This is the direction of motion, right? So what should I write for F net now? F minus T2 or T2 minus F? Motion is in forward direction. So F minus T2 is equals to M3 into A. Clear? See, like this, you have to write the equations for the given blocks. Two equations or three equations, like how many are required for our, for solving our problem. Accordingly, we write them. Okay. Same. I hope you are clear with this. If not, just kindly go through it once. Same like how we did with normal reaction. Same. In the place of N, we'll take T. That's it. We'll do one question so that concept will be clear to you. Three blocks, okay, with masses M, 2M and 3M. They are connected by the strings. They are connected by the strings. So what force is present in the string? Tension force is present as shown in the figure. See, this is how they are connected. After an upward force F is applied on block M. So on the block M, you can see in the figure, upward force is applied. The masses move upward at constant speed v. See, force is applied. So definitely there will be change in state of the body. So the bodies are moving now. But according to the question, they are moving with constant speed. So what about change in velocity with respect to time? It's nothing but acceleration. Constant speed. So change in velocity is zero. So 0 upon delta t. This is again 0. So what is acceleration here? Acceleration is 0 because the body is moving with constant speed. What is the net force on the block of mass 2m? So you have to calculate net force on the block of mass 2m. What is acceleration formula that I told you? It's nothing but F net upon m net. So F net is 0 since A is 0. F net upon m net. What is F net now? F net is 0. F is equals to ma, right? If A is 0, what is the net force? Net force is also 0. Clear? Everyone? Ma'am, you told to draw something free body diagrams, etc., etc. You can do it, not an issue. They're asking for the block 2m, right? So this is your block 2m. F is in the upward direction, right? So acceleration is also in the upward direction. And what is that acceleration? 0. So you just apply the free body diagram concept. First step, you calculated A. A is 0. Don't do like, ma'am, F net is F and M net is 6m. Don't do that. Because here the masses are moving with constant speed. If they are moving with constant speed, what is the acceleration? 0. So we are doing in the same way, but there is a tricky part in the question. Since the bodies are moving with constant velocity, the change in velocity is 0. So that means acceleration is 0. So this is the first step. And second step, you will be doing free body diagram, right? Do that here for the block 2m. So away from the block, tension, let it be 1. Away from the block, tension T2, let it be. Now what do? We apply F net is equals to M into A. And what is F net here? What is F net? F net is 0, right? Why it is 0? Tell me. They're asking the net force. See, acceleration is 0. That means the block is not accelerating. So what does it mean? It means T1 will be equal to T2. If you are confusing, just do it in the same way. You will get not an issue. So what is F net now? T1 minus T2 is equals to 2m. This is the mass into A. Acceleration is 0. So I'll get T1 minus T2 equal to 0. So this implies T1 is equals to T2. That means tension forces in the first string and the second string, they are equal. If you see here, tension forces are equal and they are opposite in direction. So what is F net now? They are equal. F net is T1 minus T2 and that is 0. Got my point? So however you do, you will get the answer. But my suggestion is you are preparing for competitive exams, so follow the shortcuts. Constant speed, acceleration 0. So F net also 0. Next we'll move on to single fixed pulley, which is also called upward mission. Where have you seen this? Have you observed this kind of situation in villages where people will be, pulling the water, in a well? What do? They use this single fixed pulley, right? Did you recollect? Yes. So, what is this single fixed pulley? That means the masses are attached to one pulley. There will be only one pulley system. Then it's called single fixed pulley. You can treat this in the same way, like if you carefully observe this, m1 mass, m2 mass, they are connected with the rope, right? So what will be the force in this rope? It's nothing but tension only. It's the same rope which is passing over the pulley for m1 and m2. So tension will be same in this entire rope. Yes or no? So away from the mass, tension, away from the mass, tension, and this tension is same because it's the same rope. And what are the other forces? Instead of external forces, we'll have the weight of the objects here. So weight here is mg, that means m2g. Here weight is m1g. So if I redraw this diagram, m1 body connected with rope to m2 body. So this side we have m2g force, and on the left side we have m1g force. In between, away from it tension, away from it tension. See, this is how the diagram is, right? So in between we have a pulley, fine. So if you just flip this, if you just rotate it by 90 degrees on both the sides, so you'll get a straight line arrangement, m1 m2. Left side it's weight m1g, right side m2 weight m2g. So don't you think it's the same motion of connected bodies? And how do you calculate acceleration here? A is equals to F net upon M net. And what is the F net here? Two forces are there. If you see the diagram here, single fixed pulley diagram, you can see the position of M2. It is a bit lowered, right? That means its mass is more. So this is the direction of acceleration for M2. As it is connected, M1 will accelerate upward. Why M2 is accelerating down? Because its mass is more. So how will you take the F net now? M2 mass is more. So M2g minus M1g. This is the F net. And what is the M net? M1 plus M2. Clear? And second part, we have to calculate the tension force. How will you calculate? Same strategy. Take the free body diagram for M1, M2. Form the equation, simplify them, you'll get the answer. That is one way. But Atwood mission is the more common in our syllabus. So directly we'll remember the tension formula. Tension formula is 2m1 m2 upon m1 plus m2 into g. See, if you can construct the free body diagram, write the equations, solve them, find out the answer of t, that is also fine. That is also fine. Okay. If you remember the formula, that could be much better because it will save your time. That's it. So two formulas are important. Acceleration is same, F net upon M net, and tension 2m1 m2 by m1 plus m2 into g. Clear with this? Remember the formulas, two formulas. First formula, second formula. Important. Memorize them. Done memorizing? Okay. We'll do some questions now. See, these are the formulas. Tension formula 2m1 m2 by m1 plus m2 into g. It's only for a single fixed pulley. But later on, we'll be dealing with multiple, pulleys, multiple connected systems. So there you have to go with the free body diagram only. Okay. See this question. Two bodies of masses 4 kg and 6 kg. So 4 kg, 6 kg are tied to the end of a massless string. String in the sense you'll have tension in it. The string passes over a pulley. And how many pulleys are there? Only one pulley. So this is a single fixed pulley system, which is frictionless. Fine. The acceleration of the system in terms of the acceleration due to gravity. So you have to find the A value. First of all, see the masses here 4 kg, 6 kg. 6 kg is more, right? So it will move down. This is the direction of A. With the same acceleration, 4 will move up. Why same acceleration? This is motion of connected bodies, right? Same acceleration. And what is this acceleration formula? F net upon M net. What is F net here? Their weights you have to consider. What is the weight of 6g? I mean 6 kg. It is weight is equals to m into g. So 6 into g. And what is the weight for 4 kg body? Again same. W is equals to m into g. So this is 4 into g. So what is F net now? 6g minus 4g. Divided by what is m net? 4 plus 6. So I'll get 2g upon 10. If you see the options, options are in terms of g only, so don't substitute the value of g. So how much will you get here? G by 5 meter per second square. Clear? 2 1 times, 2 5 times. So g by 5, it is in option number C. Very simple. If you want, you can remember the acceleration formula also for single fixed pulley. It is m2 minus m1 upon m1 plus m2 whole into g. This is also fine, whichever you feel like. Next, we'll see a small, bit extension of our concept. There is a rope of length L. Let this be the rope whose length is L meters. And for this L meters, what is the mass of the rope? It is capital M. And this is hanging from a rigid support. Fine. The tension in the rope at a distance x from the rigid support. So from the rigid support, you have to take a distance of x. Now at this point, you have to calculate how much is the tension. So you have to calculate tension at a distance x from the rigid support. How do we do this? Simple concept. Like if you take, this is the support, this is a rope. Imagine there is a mass m is hanging over it. Okay. Generally, how do we do? How do you calculate the tension here? Actually, tension is a force in the rope, and that force is supporting what? It is supporting the weight of the mass, right? M into G. The tension is supporting the weight of the body, weight of the block. So, what is the tension here? Nothing but M into G. Nothing but the weight. And which weight will you take? The weight exactly below this point, right? Are you getting my point? Which weight will you take? This entire rope is supporting the mass M at this point A. So at point A, how much mass is attached? So you will take the weight due to that mass. Now apply the same logic here. The whole length of the rope is L, but you have to take the tension at distance x from the support. That means at this point you have to find the tension. So here tension is balancing how much weight? Only the weight due to this remaining part, right? If you take the remaining part, it is L minus X meters. So for L meters, it is M kg. What about for 1 meter? 1 meter mass will be M by L kg. Now in the down, we have L minus X meters. So what will be the mass? 1 meter mass into L minus X meters. So this is the mass of the rope for the remaining distance. So this remaining part, you can assume it as a block also, no problem. You can assume it like a block. So you have to find the tension here. So exactly below it, imagine there is a block. So that block weight will be balanced by the tension. And what is the weight of that block now? It is M into G. So mass is M by L into L minus X. This is the mass into G. So this is the weight. And this is also the tension. So tension is equals to what? I'll just rub this. So you know tension will be balancing the weight, so which is equals to mg, first point. Second point, for this case, you have to find the tension at this point, distance x below the support. That means it is balancing the remaining L minus x. So what will be the mass of that remaining L minus x? For 1 meter, it is m by L. For L minus x meters into L minus x. So into G as it is. So this is the tension. Got my point? Instead of memorizing the formula, better memorize the concept. Clear? Now, we'll move on to the next topic, constraint motion. What is this constraint motion? Restricted motion in a simple way. This is also called restricted motion. Imagine your school. When your school teacher is there, you will walk You know, I mean, you will walk in a Sida Sada way. That means you'll go in a disciplined way. But you wanted to move in zigzag way. You are running here and there, but suddenly teacher has come. So what will you do? You'll move in a disciplined way. That means your motion is restricted. So restricted motions, that means you want to move in some different way, but you are not allowed to do so. That's called constraint motion. Like you can consider single fixed pulley here as an example. See, M2 is moving down because of its more weight, M2G. So this is the direction of acceleration. If imagine if M1 is not connected here, M1 is not connected with the rope, then how M1 will move? Because of its weight, it will fall down, right? But M1 is not falling down. Why it is not falling down? Because in the diagram it is connected with the rope. If it is not connected, it will fall down. But it is connected here. Because of the connection, what happens? Tension is acting and the tension is balancing the weight. So that is why M1 is not falling down now. That means it has to fall down, but that downward motion is restricted. It is connected with the rope to M2. As M2 is moving down, M1 is forced to move up. Now, this is the direction of motion. Though its weight is acting down because of the connection here, M1 motion is restricted. Instead of moving down, it was allowed to move up now because M2 is falling down. So, M1 has to move up. No other option for M1. So, this kind of restricted motion is called what? Constrained motion. I hope you are clear with this. Very simple. What is the weight direction on M1? It is downward, right? But will it move downward? No. How it will move? It will move in upward direction. Why? Because it is connected. If M2 is moving down, no other option, M1 has to move up. That means its motion is restricted and it has to move in upward direction only. So this is what called constrained motion. Okay. Two important points that you have to remember for exam point of view. Whenever there is a constrained motion, see sum. I'll change the color. Sum of dot product of tension and acceleration will be 0. Similarly, sum of dot products of tension and velocity is also 0. Remember these 2 points, what they are exactly, I'll make you understand. Sum of dot products of tension and acceleration, tension and velocity will be 0. Clear? We'll take the same single fixed pulley. Earlier, how did we calculate the acceleration? We calculated it by F net is equals to M net. And what did I tell you there? I have told you that if M2 moves down with acceleration a meter per second square, the same acceleration M1 will move in upward direction, right? Why is it so? Why same acceleration? Because they are connected, fine. But how? Let us see here. Let us apply the first point. Sum of dot product of tension and acceleration is 0, right? What is actually A dot B? It is magnitude of A, magnitude of B, and cos of the angle between them. So let us apply the same case here. How many bodies are there in our diagram? Two bodies are there, right? Number one and number two. See, for the first body, acceleration is downward. And how about the tension? Away from the mass. So tension is upward. So what is the theta now here between T and A? They are in opposite direction, anti-parallel. So 180 degrees is the angle. If you take M1, it is moving upward. Acceleration is upward. And tension is also upward. So what is the angle here? Same direction, parallel, so 0. So just substitute that stuff here. For the first body, AB cos theta, right? So TA cos theta. T1, A1 cos theta 1. Next for second body, T2, A2 cos theta 2. This summation should be equal to 0. Now just simplify. It's the same rope. So T1 value, T2 value will be same. It's T only. So we'll write it as T A1. What is cos theta 1 for the first block? It was 0. Similarly, T2 is T, A2 is A2 only. Cos theta 2 theta is 180 degrees. This is equals to 0. Simplify, how much will you get? So T A1 cos 0 value 1. T A2 cos 180 is minus 1. So if I send this negative term that side, I'll get TA1 is equals to TA2. TT cancel. So what will you get? A1 is equals to A2. So acceleration is same for both the blocks. So the same thing we have proved here. This is what we have studied in the beginning, right? For the connected bodies, acceleration will be same. And this is what we have proved here. Okay. But in the problems, here we are proving, but in the problems, these concepts are really important. Point 1 and point 2. Using the T dot A, T dot V, we can find out the unknown accelerations, unknown velocities, or tension in the rope. So they are really helpful in some problems. So remember them. Clear? Now, next important point, velocities along the string will be same. What is this? Let us understand. Velocities along the string will be same. Why they should be same? Because acceleration is same now. Fine, we'll understand with some example. See, this is a pulley. Imagine a mass M2 is hanging here. What will be the tension away from the mass? Now imagine there is a block on horizontal floor. Its mass is M1. It is, see, it is moving freely. Okay, it is movable block. Let me write it here. We are not fixing the block on the floor. It is just movable, flexible. Okay, and this is how it was attached. Now away from the mass, again tension. With the horizontal, let us assume that it is making some angle theta. Now, if I assume that this M1 block is moving forward on the floor. Imagine somebody is pulling the M1 block on the floor. It is movable. So it was moving in this direction. So what is the direction of M1? This is the direction. So velocity V1 is in this direction. Now, how about the M2? M1 was moving in the left side direction. So it was moving interconnected. So what will be the direction of motion of M2? This is how it moves, right? So let its speed be V2. Now just apply the same logic. Summation of dot product of T and A should be equal to 0. Let us apply that. What will you get? What is theta 1 here? Between V and T, what is the angle? This angle. See, the whole is 180 because angle in a straight line is 180. So what about this angle? I assumed theta on the other side. So it will be 180 minus theta. And here V and T, they are in same direction. So here theta is 0. So tension is same because it's the same rope. Okay, first let me write normal formula. T1 V1 cos theta 1 plus T2 V2 cos theta 2 is equals to 0. Now for the first block, T1 is T only and V1 is V1 only. Cos theta, this is cos 180 minus theta plus T2 is T, V2 is V2, cos theta 2. What is cos theta 2? It is 0 degrees. This is equals to 0. So T V1, what is cos of 180 minus theta? 180 minus theta is in second quadrant, right? Sign is positive, remaining all negative. So you'll get minus cos theta plus T V2 cos 0 value is 1. This is equals to 0. So send the negative term that side. What will you get? T V2 is equals to T V1 cos theta. So T cancel And what did you get the relation here? V2 is equals to V1 cos theta. This is what we got, right? Now, if I ask you, V2 is along the string, it's in the same direction of the string. V1 is not along the string. V1 is something in backward direction. And along the string, what is the direction? I mean, what is the speed of V1? V1 is actually in backward direction. But if I ask you, what is V1 along the string? What will it be? It is 180 minus theta, adjacent component, right? So what is adjacent component? Vector cos theta. Cos of 180 minus theta minus cos theta. So how much will you get here? You will get V1 cos theta. Fine. Or else you can do one thing, you know this angle, right? Theta. If you reverse this V1, what will you get here? It will be plus V1. Then adjacent side V1 cos theta. That is also fine. If not, minus V1 cos of 180 minus theta. Then also you'll get V1 cos theta. So now if you see velocities along the string, they will be equal. That is what we kept the heading. And here is the proof. So let there be any bodies. If you take their velocity components along the string, that will be equal. You will get the questions like how much is this theta? How much is the value of V1? So no need of doing this every time T dot V equal to 0. You can directly use this funda. Velocities along the string are same. So if you take for M2, it is V2. If you take for M1, what is velocity along the string? V1 cos theta. So these two will be equal. Equate them, find out the answer. So directly remember this concept. Velocities along the string will be same. Clear? Just revise it for once. Now we'll move forward. Impulse and change in momentum related to Newton's second law only, a bit extended concept. So there we have discussed force is equals to rate of change of momentum, right? Now if I take change in momentum, it is F average. This is actually F average. Average force into delta T. See, this change in momentum is actually called impulse. So what is impulse? It's nothing but change in momentum only. And that is actually the product of average force into change in time. So when a large force acts on a body for a very small time, then the product of that force and the time is called your impulse. So it's simply the product of force and time. Where do we observe this impulse? You can take a person playing a football and the fielder, he's catching the ball. When he catches the ball, see, the ball is coming with a greater force and he's catching the ball in a fraction of seconds. So if you take now the force that was acting and the time of the catch, so what is that force into time now? It's actually impulse. Large force acting but for a very short interval of time. See, he catches the ball in the sense what? Will he take 1 hour to catch the ball? No, right? He'll just catch like that and he'll just leave the ball. That means huge force is acting on the hands, but that force is acting for a very short time. In such cases, the change in momentum is called your impulse. So impulse is change in momentum, which is F average into delta T. That means, can I take the area of the graph between F and T? Because we are doing multiplication here. And I told you in the last class also when we were discussing Newton's second law. Change in momentum is area of the graph. This is important because there are many questions. So many PYQs are there in Neet papers based on this concept. So this is important. See this one. The force F acting on a particle of mass m is indicated by the force time graph as shown. Okay. The change in momentum. So you have to calculate the change in momentum of the particle over the time 0 to 8 seconds. So from 0 to 8 seconds, that means you have to consider the complete graph. So what is change in momentum? Nothing but area of the graph, right? So you can divide it like first segment, second segment, third segment. What is the area of first segment? triangle. So half into base into height. How much will you get? Half into 2 into height is 6. So you'll get 6 Newton second. And if you take the second segment, what is the area? It's just a square. So side into side. It is not a square. Sides are not equal. Consider it as a rectangle. So length into breadth. So what is the length? It is 2. And what is the breadth? Minus 3. So I'll get minus 6 Newton second. See, impulse is a vector quantity. Let me write it here. Impulse is a vector quantity. So for vectors, we consider the sign. If it is plus, plus only. Minus means minus only. And for the third segment, again it's a rectangle. So L into B. What is the area? It is 4 into 3. So this is 12 Newton second. Now what is the complete area? It is first segment plus second segment plus third segment, right? So if you see plus 6 minus 6. First one was plus 6. Next one was minus 6. Plus 12. So plus 6 minus 6 cancel. You will get 12 Newton second. So what is the impulse? What is the change in momentum? 12 Newton second. Clear? See this one. A stone is dropped from a height h. So stone is dropped. That means initial velocity is 0. So what is this height? It is height h. It hits the ground, okay, with the momentum p. If the same stone is dropped from a height 100% more than the previous height. So this was the first case. What is the second case? Stone is same. This time it is dropped. That means initial velocity is 0 again. But this time the height is more. How much more? 100% more. That means this time height is 2h than the previous height. Now this time when it is hitting the ground, what is the momentum? So the momentum when it hits the ground will change by. So let it be P1 here, let it be P2 here. They are asking change in momentum. That is what they are asking. Understand the question? Dropping case in both the cases. Initial velocity is 0. When it hits the ground, momentums are respectively P1, P2. Heights are different here. First case it was H1. I mean H1 is H. Second time it was 100% more. That means it is double. So we want actually change in momentum. And if you see the options, it is percentage change in momentum. You need to calculate percentage change. So we'll do one thing. First, what is P1? Momentum is m into v, right? So m into v1. What is the velocity when the ball hits the ground? It is under root 2 into g into h, right? So m into 2 into g into h. What is P2? Same formula m into v, but velocity is different. So v2. So m into 2g. H is how much? 2h this time. In the second case, height is 2h. So shall I write it as root 2 into m into root 2gh? Let us take it as x. Now this will be what? Root into x. Because m into root 2gh, instead of using it every time in the calculations, just to save the time, assume it as x. P1 is x, then P2 is x root 2. Now what is a percentage change in momentum? So percentage change in momentum is P2 minus P1 by P1 into 100. Ma'am, how do I know it is P2 minus P1 only? Because in second case, momentum is more, right? Momentum is m into v, and v is directly proportional to root h. So height is more in the second case. So velocity is more, momentum is more in the second case. Now just substitute P2 is x root 2 and P1 is just x by x into 100. So how much will you get? Numerator x, take it out common, will get root 2 minus 1 by x into 100. So what gets cancelled here? X cancel. So root 2 minus 1, root 2 is 1.414 minus 1 into 100. So I'll get 0.414 into 100. So how much will it be? It will be 41.4%. So this is a percentage change in momentum. 41.4. Okay, approximated value is given 41%. This is also fine. Clear? Any difficulty? See, all the time you have to be thorough with the previous concepts. Ma'am, why did you take V is equals to 2GH here under square root? Because we have studied in 1D, right? Use V square minus U square is equals to 2AS formula. You will get final velocity is equals to root 2GH. The velocity of a body when it touches the ground. Velocity of a freely falling body when it touches the ground is square root 2GH. You have to be thorough with all these, okay? When you are going for the next chapter, you have to be thorough with the previous chapters, okay? See this question. A cricketer catches a ball of mass. This is the mass. Mass is 150 grams. So I'll write it as 150 by 1000 kg in zero point 0.1 second. So time is how much? 0.1 second. Moving with a speed. So what is the speed of the ball? 20 meter per second. Then he experiences a force of. Now, is this speed initial speed or final speed? Read the question carefully. Cricketer catches a ball. When he catches a ball, the ball will stop moving, right? So, final velocity will be zero. So, what the velocity given here is initial velocity. When the cricketer catches the ball will not move further. So, final speed is zero. So, the given speed 20 meter per second is an initial speed. So, you have to calculate the force. So, shall we use the impulse concept? So, change in momentum is nothing but F into T. What is change in momentum? What is momentum? First of all, M into V. What is change in momentum? M into V minus U. So, just substitute here. Mass is 150 by 1000. V, final velocity 0, initial velocity 20 is equals to F. We have to calculate. And what is the time? It is 0.1. So, I'll write it as 1 by 10. Now do the cancellations. 0, 0, 0, 0. So you'll get 5 twos, 5 threes. So you're having 3 by 2 into minus 20 is equals to F. So how much will you get? 2 ones, 2 10 times. So F is equals to 3 into minus 10 minus 30 newtons. Why it is minus 30? Why not plus 30? See, because the cricketer is catching the ball, right? The force is applied in opposite direction of the ball. Ball was moving forward, but the cricketer has caught the ball. So his force is in opposite direction. That's why minus. So answer is option B. Whenever you see minus, don't bother. It means the force applied by the cricketer is in opposite direction. Ball was moving like this. But cricketer, when he catches the ball, so this is the direction of force applied by cricketer, right? Opposite direction. So force is negative. See this question. A bullet is fired from a gun. The force on the bullet is F is given. The force on the bullet becomes zero as soon as it leaves the barrel. So when it is leaving the barrel, force is becoming zero. Let us equate it to zero. What do we get? Let us see. 2 into 10 to the power of 5t equal to 0. So 600 is equals to 2 into 10 to the power of 5t. What gets cancelled? 2 1 times, 2 300 times, 2 zeros, 2 zeros cancel. So you'll be left with t is equals to 3 by 10 power 3 seconds. Now, what is the average impulse imparted to the bullet? So you have to calculate the impulse here. What is impulse? Impulse is nothing but change in momentum. Or you can take it as F average into time. What is F here actually? F average into T. F is not directly given, some expression is given. So what will you do? So take this formula. We have also studied this formula, right? When equations are given, when expressions are given, for F, we will take it as dp by dt. And for change in momentum, we will take integral f dt because some expressions are given. So impulse is now integral f dt. So integrate the f, what will you get? 600 integration is 600 t minus 2 into 10 to the power of 5, t integration is t square by 2. And apply the limits 0 to 3 by 10 power 3, you can take it as t in 3 into 10 power minus 3. Just substitute and simplify, what will you get? So 600 into t, 3 into 10 power minus 3. I'm substituting upper limit. 2 to cancel. So I'll get 10 power 5 into t square. What is t square? 3 square is 9 minus 3 square is 6. This is the substitution of upper limit, and lower limit substitution is 0 because every term is having t in it. So what will you get? 6 threes are 18 plus 2 zeros minus 2 zeros cancel. You will get 10 power minus 1 minus 9 into 10 power 5 positive zeros, 5 no negative zeros cancel. So I'll get again 10 power minus 1. So how much will you get here? 1.8 minus 0.9. So I'll get 0.9 again. So this is the impulse. You'll get zero point 0.9. Are you clear with this? Don't take f directly because f is expressed in terms of t. F is dependent on time here. So when it is dependent, how will you take the product? You have to integrate. Integral f dt. So answer is zero point 0.9 Newton seconds. Option D. We'll see one more problem. A particle of mass m is moving with a uniform velocity v1. It is given an impulse such that its velocity is becoming v2. That means initial velocity is v1, final velocity is v2. What is the impulse? What is impulse actually? Change in momentum. Change in momentum is m into final velocity minus initial velocity. So m into final velocity v2, initial velocity v1. So m into v2 minus v1, which is option D. See, directly based on the formula. This was asked in 1990. See this question. See, before I solve the question, try to do it on your own. Mass is 0.15 kg, dropped from a height of 10 meters. The ball strikes the ground and rebounds to the same height. Okay. First case, the ball was dropped, so initial velocity was 0. How much height? 10 meters. So it will strike the ground. And what will be the velocity by the time it strikes the ground here? That is nothing but root 2gh, right? How much will it be? Root 2 into g value 10, h value 10. So root 200. So this is 10 root 2 meter per second. This is the velocity with which it will hit the ground. So after hitting the ground, what is the continuation of the question? It is rebounding to the same height. That means the ball after striking the ground, it is rebounding to the same height 10 meters. That means after going 10 meters, its final velocity is becoming 0. And what will be the initial velocity here? When it was rebounding, when it is going back, what is the initial velocity? Use this formula, h is equals to u square by 2g. So u square is equals to 2gh. So u square is equals to 2 into g10, h is 10. So what is u value now? It is again 10 root 2. So when the ball is rebounding, its initial velocity is again 10 root 2 meter per second. Fine. The magnitude of impulse imparted to the ball. You have to calculate the impulse imparted. Impulse is nothing but change in momentum now. Change in momentum, that is m into v minus u. So how will you calculate? M into final velocity minus initial velocity. See, in the second case, when it was rebounding, that is your final velocity. When it is rebounding, this was its final velocity. When it was striking the ground, that was its initial velocity. You have to take for the whole, right? Falling on the ground and then rebounding. You have to consider all together. So initial velocity is the velocity with which it is touching the ground. Final velocity is the velocity with which it is rebounding. Now just substitute that stuff here. M is 0.15 kg. That means 15 by 100. What is final velocity? It is going upward, so plus only 10 root 2. Initial velocity, it is coming down, so again minus 10 root 2. Vectors, right? Take with the sign convention. So 15 by 100, 10 root 2 minus of minus 10 root 2. So it is plus, right? So I'll get 2 times 10 root 2. Now simplify this, how much will you get? 0, 0 cancel. 2 one time, 2 5 times, 5 one time, 5 3 times. So how much will you get? 3 root 2. So 3 into root 2 is 1.414. So the answer is more than 3. 3 into 1 is 3. Extra 0.414 is there. So approximately if you see the options, the closest option is 4.2. So answer is 4.2. Clear with this? When it was falling on the ground, it will touch the ground with some speed. That will be the initial speed. This v is the initial speed. When it is rebounding, it moves up with certain initial velocity. That is your final velocity here. Okay. This was asked in 2021. Same model question. It was asked in 2025 again. Same model. I'll just give you the hint and I will leave it to you only do it. This time mass is 0.5 kg. Fine. Dropped from a height of 40 meters. Ball is dropped from a height of 40 meters. Fine. The ball hits the ground and rises to a height of 10 meters. So this time the ball is rising only to a height of 10 meters. The impulse imparted to the ball during its collision. So you have to find the impulse, nothing but change in momentum. So this is m into v final minus v initial. Mass is how much? 0.5 kg. So you can write it as 5 by 10. What is final velocity and initial velocity here? The ball is moving up right here. So with how much speed it is moving up, that is your final velocity. It is hitting the ground, right? With how much velocity it is hitting the ground, that will be the initial velocity for our case. So with how much velocity it will hit the ground, use this formula. V is equals to 2gh. So 2 into g value 10, h value 40. So how much will you get? So 4 you can write it as 2 square, 10 you can write it as, 100 you can write it as 10 square, 2 as it is. So I'll get root 2, 2 into 10. So this is 20 root 2 meter per second. So this is your V initial. How will you find V final here? Use this formula, h is equals to u square by 2g. H is 10, u square, 2 into g, so 20. So u square is 200. So what will be u? This is 10 root 2. And what is this u actually? This is the final speed, right? So this is final velocity. Not just substitute here. Final velocity is 10 root 2 because it is moving up. And initial velocity, it is coming down. So minus of minus 20 root 2. So how much will you get? 5 by 10 is 1 by 2. 10 root 2 minus minus plus. So 10 root 2 plus 20 root 2. How much will you get? You'll get 30 root 2. 1 by 2 into 30 root 2. So it will be 15 root 2. So it will be 15 into 1.414. So it will be more than 15. So more than 15, two options are there. It cannot be 84, right? Slightly more than that. So you can take the answer as option A, 21 Newton second. Clear? Any confusion here? Ma'am, how this is initial, how this is final? Consider the whole system. Body was falling down and it is hitting the ground. When it is hitting, that was the initial velocity for this entire question. When it is rebounding, that is the final velocity for the complete question. You have to calculate the change in momentum. See, when the ball is hitting the ground, there is a collision between the ball and the ground, right? So there will be a change in velocity. When it is hitting, some energy will be lost, some velocity will be lost. So there will be a change in velocity. Where there is a change in velocity? During the collision. So before collision, initial velocity. After collision, final velocity. Okay. Now, okay. So this concept we'll do it in the next class. So any doubts so far? Just recollect once what we have discussed in today's class. So today we have understood how connected bodies move together and how to analyze the systems like upward motion and also constrained motion, and how impulse changes the momentum of bodies during interactions. These are the topics that we have discussed today. These topics are not only important for your exams beta, they also help you develop logical thinking in physics. So if your basics of force, acceleration, momentum, etc., if these concepts are clear, the questions of today's class are very easy to solve. So revise the formulas, revise the previous chapters, practice the number of numericals that you can, and try to understand the concept rather than memorizing the formulas. So thank you for joining the class. Keep learning, keep practicing, and I'll see you in the next session. Bye bye.